Welcome to this video introducing our work titled I Dream My Painting, connecting multimodal LLMs and diffusion models via prompt generation for text-guided multimasking painting. If you're interested in this work, please scan the QR code at the bottom of this slide to access our project page. Diffusion models are state-of-the-art in text-guided imaging painting, where new objects have to be painted in an image in place of a mask following a text prompt given by the user. In this paper, we aimed to address some limitations that arise when using these models. First, text-guided imaging painting is limited to a single mask, which makes it difficult to create complex arrangements of objects to be painted. Second, these models require strict user guidance to insert objects, and will result in painting background textures or objects from their skewed initial distribution when asked to paint using general prompts, such as a plausible object. Finally, the most common approach to adapting models like Stable Diffusion to Inpainting consists of fine-tuning the model on randomly obtained masks using the image description, which results in the problem of text misalignment, where describing the object to Inpaint does not always provide the required result. In particular, diverse image painting has been tackled by different works. Repaint was one of the first adaptations using an unconditional diffusion model to obtain diverse image completions, leveraging the stochastic nature of the denoising process. In From Posterior Sampling to Meaningful Diversity in Image Restoration, the authors designed a strategy to steer multiple parallel denoising processes to get a certain number of completions that maximize diversity. Finally, Brush to Prompt is the first work that uses text-guided inpainting models and aimed to generate prompts automatically by using a denoising process in clip space to generate the text or embedding inputs of a diffusion model. However, their work is limited to single mask painting. In this paper, we introduce a new task, text-guided multimasking painting, where we aim to inpaint different image regions simultaneously, with each region following a different text prompt. Furthermore, we consider the possibility of generating these prompts automatically to create a pipeline that can generate plausible and creative completions given the information about the mask sizes, positions, and the unmasked content of the image. The generated prompts could serve as suggestions in image editing tools, enhancing creative workflows. We analyze a dataset of artistic images from WikiArt, linked to artworks in the Art Graph knowledge graph. We focus on paintings because they include a wide variety of real and fantastical objects, making them a challenging and interesting test case. This also helps us showcase our automatic data annotation pipeline, which can work with the image datasets from different domains. To train our system, we need object-level text annotations for the images. We generate these automatically using Cosmos 2, a multimodal model that gives a general description of the image and identifies the main objects with bounding boxes. We then crop these regions and use Lava to provide detailed descriptions of each object. At the end of the process, we obtain annotations for more than 100,000 images. Our pipeline consists of two components. The first is the prompt generator, which takes a corrupted image with masks as input and generates suitable prompts for each region to be painted. The second component is the diffusion model for inpainting, which should generate the objects described by the prompts within the corresponding masks in a single pass. To implement our method, we use Lava as the prompt generator and Stable Diffusion 2 Inpainting as the inpainting model. Both components are fine-tuned for our task using parameter-efficient techniques such as QLoRa and LoRa. For prompt generation, we designed the following fine-tuning task. Given an image with object annotations, we assign a random color to each object and mask it using the corresponding color. We then describe the task in the instruction prompt, listing the colors in a specific order. The ground truth consists of object descriptions with color delimiters, arranged in the same order as the colors in the instruction prompt. The objective is to minimize the language modeling loss for each ground truth token, conditioned on the preceding tokens, the system and instruction prompts, and the corrupted image. We adapt stable diffusion to multi-mask painting by using the rectified cross-attention technique from FreestyleNet, originally designed for layout-to-image synthesis. In our approach, the binary masks of the objects act as a layout. The attention maps of a text-to-latent cross-attention layer are the other input of the rectified cross-attention algorithm. Each object's mask is repeated for all tokens related to its description, creating a binary tensor with a shape of T by H by W, where T is the number of tokens in the prompt formed by combining all the region prompts. These binary maps adjust the model's attention, ensuring that tokens for a region only focus on the spatial locations inside that region. We also allow attention between tokens related to multiple objects and overlapping regions, and enable all tokens to attend to the unmasked parts of the image. We compare prompt generation approaches on the test set using the base lava model with a specific prompt as the baseline, which we called lava prompt. Our findings show that the model struggles to understand the task of multi-mask prompt generation, so we restricted the comparison to single-mask prompt generation. The reported metrics evaluate the plausibility of the prompt generation process by comparing the generated prompts to the ground truth objects. Our results indicate that training the model in the multi-mask setting yields better performance in terms of blur and clip similarity between the object crop and the generated description compared to a variant trained for single mask in painting. We also present results for multi-mask prompt generation across all annotated objects, showing that there are similar performances when considering more than one mask for prompt generation. For multi-mask painting, our model achieves slightly lower results compared to a variant of stable diffusion fine-tuned on our dataset, which uses a repeated inpainting process. However, the latter is a more resource-intensive approach. Interestingly, we compare the results between our variant with the generated prompts and the model with the general prompt high quality, and find out that there is a gain of 2 clip similarity points, showing that prompt generation can provide more plausible completions. In this slide, we present qualitative results of our pipeline on photographic images from the densely captioned images dataset. As we can see, we obtain creatively generated prompts that result in higher quality completions compared to using a general prompt such as high quality. Furthermore, our adaptation of the RCA technique enables better alignment of region prompts. In this slide, we present results on 5 masking painting with the generated prompts on the artistic dataset. Here, too, we achieve better prompt following a region alignment. For instance, in the second row, the RCA application allows the model to inpaint the dog in the required region. We conduct additional experiments, such as domain transfer on the left, where we compare the application of our pipeline trained on DCI and the art dataset in completing photographic images. We observed that domain transfer enables more creative and colorful results. On the right, we provide an additional comparison against repeated inpainting. While RCA shows slightly worse region alignment scores, the qualitative results suggest that inpainting all objects simultaneously leads to more natural completions. This is especially evident in the second row, where the basket and rock appear to have been pasted onto the image by the repeated inpainting process. In conclusion, we present a pipeline that combines MLLMs and diffusion models for text-guided multi-masking painting. Our results show that diverse, plausible prompts and good region prompt alignment can be achieved, even for challenging domains like the domain of paintings. Future work will focus on reducing resource requirements and comparing simultaneous versus repeated inpainting for completion quality. Thank you very much for listening to this presentation.